5.2b, scale drawings. So we are going to move ahead with problems that use the lessons that we had before break, the lessons where we used proportions. So everything this week that we're going to do, it's going to use proportions. And one of the most common is scale drawings. So scale drawings are drawings that represent something that's very, very large, because you couldn't put that all on paper, or something very, very small so that you can actually look at what's in there. So scale drawings are used by a lot of people. They're used by builders and anything to do with the building trades. They're used by engineers and architects. So all different kinds of occupations, you would have to know how to use a scale drawing. So there's also a scale model. Does anybody in here do model cars?
I do model planes.
Model planes? Anybody else do any kind of models? So I guess building model cars must be a dying art, because a lot of kids, and I hate to say boys, but back in the day, a lot of boys used to do model cars. Yes?
There was like these model, like, kind of plastic gun things that you would put together, and I did a couple of those back in the
Okay,
day.
okay. So there's different kinds of model things that you can make. So a scale model can also be used to represent something that is too large or built too small for an actual size model. I will tell you that people sometimes have a model built first before they have an actual thing built. So scale models can be built to represent things too large or too small. And so those things are built to a scale. A scale gives the relationship between the drawing or the model measure and the actual measure. A scale is something, if you read a map and it says 1 inch equals 50 miles, that's a scale. They tell you how the dimensions work. They say what it is in reality compared to what it is on that scale. And if you're using the standard units of measure, it would be inches and feet or yards or miles. If you're using metrics, then you're of course comparing maybe millimeters to meters or something like that, or centimeters to kilometers. But you're given a scale. Well, whatever that scale is, that's what it has to be throughout the whole thing. So when you are looking at blueprints, so if you grow up and you want to build a home and the builder's going to come to you and ask what you want, you're going to say, well, I want this and this and this. And he's going to go through and he's going to have to make sure that everything on that paper is exactly proportional to the same measurement all the way through, because those blueprints, yeah, he draws it for himself, but then it also has to be used by the electrician and the plumber and the people that put in the cabinets or the flooring, and it's all going to be accurate. So they know exactly what they're getting into when they have to bid how much it's going to cost, right? They don't want to just have some random amount and then not make enough money for what they do. So anyway, the scale gives the relationship between the two things. So if we're looking at this example that they have right here, it says on this map, each grid unit represents 50 yards. Each block represents 50 yards. And it says find the horizontal distance from Patrick's Point to Agate Beach. So we're talking this distance right there. And they actually counted that it was 8 units. Well, you set up this proportion. You do fraction bar, equal sign, fraction bar when you're doing this. And you decide what you're going to do. Remember me telling you when we wrote proportions, you always put a note out to the front, what you're comparing? This one I would put units to yards, because that's what it's talking about. Each unit represents 50 yards. So 1 unit to 50 yards, this thing is 8 units, and then X yards. And see, we would do the cross. We've talked about that a lot before break. Cross, and then they solve and they find out that it was 400 yards between the two. Okay, so we're going to talk about, look at some examples like this. Let's go down to the chart. So you were supposed to write some of these odd ones down. So number 1, it says, first of all, find the actual distance between each pair of cities, round to the nearest tenth, so that's important, nearest tenth. It says that we're measuring from Los Angeles to San Diego in number 1. Los Angeles to San Diego. The map distance is 6.35 centimeters. That's how long it is on the map. The scale is 1 centimeter equals 20 miles. So we have to figure out how many miles there is in 6.3 centimeters. So I'm going to write it down here at the bottom, and we'll erase it each time because I have enough, so that I have enough space. But I'm going to have a fraction bar, equal sign fraction bar. Make sure you write these notes to yourself. Now, what are the two things that we're comparing? What's in the scale? What are the two things we're comparing in number 1?
6.35 and 20.
But what's the scale? What's the units of measure that we're comparing?
Centimeters.
Centimeters to
Miles.
centimeters on top and miles on the bottom. So if I look at the scale, 1 centimeter to 20 miles, where's the 1 going to go, top or bottom?
Top.
1 centimeter to 20 miles on the bottom. And now it says 6.35 centimeters. So where do I put 6.35? Top, because it's centimeters. So the bottom is what's missing. So that's X, right? Once you get all 4 spots filled in, what do you do? What do I call it?
Multiply.
Cross, cross, right? Cross, cross. 1 times X equals 20 times 6.35. Well, 1 times X is easy. What's the best way to write 1 times X?
1x.
1X? Is that the best way?
Just x.
Just X. Very good. Just X. And then you're going to be allowed to use calculators again. 20 times 6.35. It is 127. And how do you think I would label that?
X equals 127 miles.
X equals 127 miles. So if I was filling this in up here, 127 miles. 127 miles. Okay. Number 3. Number 3. We're going from Des Moines to Cedar Rapids. 16.27 centimeters. 16.27 centimeters. And it tells us the scale is 2 centimeters equals 15 miles. Does everybody have this problem written down over here on the right?
Yeah.
Okay, so let me erase that. This time, as I'm doing this, I always go fraction bar, equal sign fraction bar. Note out in the front, what are the two things I'm comparing?
Centimeters and miles.
Centimeters and miles again. Is there a rule that I have to have the centimeters on top, do you think?
Yeah.
Is there? Who made that rule?
I don't know.
Is there a rule? No, it could be miles over centimeters, couldn't it? It's You just pick one so that you know which ones are going to have which units. So the tops are going to be centimeters, the bottoms are going to be miles. Okay, here is the problem. 2 centimeters to 15 miles, 16.27 centimeters. What numbers go where? Who can do it? Dylan?
16.27 goes on top, and 2 goes on top, and then 15 goes on the bottom of 2, and then X goes on the bottom of 16.27.
And then X goes down there because we don't know what that is. Okay, so you put your 2 over 15 and then the 16.27 centimeters that would go on top because that's where we're putting centimeters, and now we're going to cross. So 2 times X equals 15 times 16.27. Okay, so 2x equals, and here's where you're definitely allowed to use a calculator. So 15 times 16.27, 244, whoops, 244,
Even?
nope, 0.05, 244.05. And now I've got 2x. How do you solve for x?
Divide by 2.
Divide both sides by 2. So x equals 244.05 divided by 2. It says 122.025, but my instructions say round to the nearest tenth. So what's that going to be? 122.0 or 122.1? 0.0. So you would write 122.0 miles. And you must put the 0 or it's wrong. Remember that? We had that discussion earlier in the year. Yes?
Well, how come you couldn't just put 122?
Because did it come out exactly to 122?
No.
No. So if you write 122, that's saying you got exactly 122. But if you put the 0, you're showing that it was rounded off. Okay?
Oh.
And it is rounded off, right? So you can't mislead whoever might be using that. It says round to the nearest tenth if necessary. So if you have to round it all, there's got to be something in that spot. Now the one up the top, the 127, we didn't have to round that one at all, did we? That one just worked out. So if you don't have to round it off, then you don't. You can leave it like that. All right, questions about any of those? So we're going to go down to the bottom now and look a little bit further here. It says, find the length of each object on the scale drawing with the given scale. Then find the scale factor. We haven't talked about scale factor, but we're going to right now. I can tell you right now, this is wrong. That isn't 6 inches. That's 6 feet. That's a typo, so change that to 6 feet. 1 inch equals 6 feet. Okay, now, every one of these I told you you're going to have a proportion. So fraction bar, equal sign, fraction bar. What's the 2 units that I'm comparing in this one?
Inches and feet.
Inches over feet. So if it says 1 inch to 6 feet, which one goes where?
6 goes on top, 1 is on bottom.
So 6 feet goes on top? 6 feet goes on top? This says inches over feet.
Oh. 1 on top.
1 on top and 6 on the bottom. Where does the 16 go?
On the bottom.
The bottom. So x goes on top, and we're going to cross. 1 times 16 equals 6 times x. So 16 equals 6x. What's the last step?
Divide by 6.
Divide by 6. So x equals, if I take 16 divided by 6, it says 2.6 repeating, but we're going to round to the nearest tenth. So 2.66 repeating. So what would that be? 2.7, and how would I label it? 2.7 what?
Feet?
2.7
Inches.
inches. 2.7 inches, because it was 16 feet long, it would be 2.7 inches. So write your scale, write your units out in front, and fill in what you've got. Now it says find the scale factor. We haven't done that yet. The scale factor is making the scale with the same units.
What?
Right now it's 1 inch is 6 feet.
Yeah.
Inches and feet aren't the same kind of measurements, are they?
No.
They're different.
Oh, so it'd be 1 inch.
So here's what it means. This is feet. Okay, I want to make sure that you understand. I'm not doing it that way. That's feet. 1 inch over 6 feet. We got to change that to the same kind of units. So is it better to change 1 inch to feet or 6 feet to inches?
6 feet to inches.
Right. So 1 inch. How many inches in 6 feet?
No. 72.
72 inches. So my scale factor, this is the scale factor. The scale factor for this is 1 over 72. Or you could write it 1 to 72. Same thing. So a pond is 85 feet across. The scale is 1 inch equals 4 feet. So we've got this set up, this proportion, we're comparing inches to feet. It says 1 inch, so 1 goes on top, equals 4 feet. So 4 feet on the bottom. I'm comparing feet to inches. If they tell me the pond is 85 feet across, where am I going to put the 85?
On the
Top
bottom.
or bottom?
Bottom.
Liam? Bottom, because that's where we decided the feet were going to go. So my inches on the top are X. Now I'm going to cross. 1 times 85 is 4 times X. So 85 equals 4X. How can I solve for X now?
Divide by 4.
Divide by 4. So X is 21.25. Now, this one, it doesn't say specifically round to the nearest tenth. I'm kind of doing it because it's above. So let's just say this one does. If we had to round that to the nearest tenth, what would it be? 21.2 or 3?
3.
The 5 says 3. So 21.3, and how would I label that?
Feet. Maybe, yeah.
It's inches because they already had the 85 feet. 21.3 inches. All right, questions on how to set those up.
How do you do the scale factor?
I'm going to do the scale factor right now. I just want to make sure everybody's got that part done. You good? So here's the scale factor. You take the scale 1 inch over 4 feet. You write it just like this. And you have to change them so that they have the same units. Can't be inches and feet for scale factor. They either both have to be inches or they both have to be feet.
Inches
What's-
is easier.
What's easier?
Inch.
Inches, because you can't change 1 inch to a feet. That would be
Maybe
too
1/12
hard.
of a foot.
So I'm going to do 1 inch. How many inches in 4 feet?
48.
Over 48 inches. Now that we've got the same unit, you don't have to write these anymore. So it's 1 over 48, or you could do 1 to 48. This is the scale factor. You write them down, however the scale's given, and then you change the units to the same thing. Sometimes you might have to simplify it. If it's a fraction that can be reduced, reduce it. These two have not been. Yes?